So let's continue with our discussion about the time value of money. In this case, we're going to work backwards. We're going to assume we're going to get some money in the future, and we'd like to know what that money will buy us in today's currency. So the present value is the current dollar of a future amount. One of the concepts we're going to think of is the concept of value. What does value mean? Essentially, it's what is it worth to you in today's money? If you had it in your hand and you could spend it, what could you buy with it? So this whole process is referred to as discounting, bringing money back from the future, bringing it to the present. Now, the interest rate that we're talking about has many synonyms. It could be opportunity cost, the discount rate, required return, cost of capital. We could also solve for inflation, returns, growth, interest rates. So there are many synonyms, if you will, for this discount at which money is growing. So in this instance, the present value, you're going to receive $1,000 in the future, 3 years from now, and the current interest rate's 13%. What is that worth in today's money? So if we go to our spreadsheet, future value is $1,000, present value is what we're solving for, interest rate's 13% times 3 years. Again, we're still talking about annual compounding. So that is worth $693.05. So a question is, if you can invest at 13%, which would you rather have? $693.05 today, or $1,000 in 3 years? And the correct answer to this is you are indifferent. You don't care. They both represent the exact same amount of purchasing power. So there are many examples that we can talk about. Some of these we'll discuss in some specific problems, some application kinds of problems, but there are many things we might want to know. If, let's just say, you thought you were going to retire in 25 years, and the very first year you were going to earn $100,000 in retirement. If inflation is 4%, what would be that worth? What would be that value in today's money? If you solve for this, what you'll find out that that's worth roughly $37,511. The question is, can you live today on $37,511? Don't know if you can or not, but that's the kinds of questions we can answer with these present value questions. The effective interest rate is the actual interest rate you earn. It is different from the annual rate in that it assumes the compounding is at work. So let's think about this compounding frequency. $1,000 invested at 12% for 6 years is roughly $1,973. But what if we calculated interest monthly rather than annually? Down below here, the compounding frequency, you would need to change this to a 12. Again, this would be an example, or this is the difference in compounding, right? What would that interest rate be? What would the value change to? Again, I suggest you do this and change the 12 to a 1 in your spreadsheet to see, number one, what does the value go to? And number two, what then is the effective interest rate? It's an interesting thought. The difference is between what's referred to as the stated rate or the annual rate and what we refer to as the effective rate. We can do problems that have mixed cash flow streams. This really relates much more to corporate decision making than personal finance. But assume you were going to do a project and these were the cash flows that you expected to get into the future for the next 5 years. We have a worksheet that's called the time value mixed cash flows. And here where you would substitute, put the cash flows in, make sure you put them in the right cells for the right period. Make sure you also include the right signs on those cells. These are all positive. We have an 8% interest rate, 5-year period. So we get two answers from here. What is the value today of getting these monies? In other words, what is this money worth to you in today's dollars? Today, you would be willing to pay $56,902 for this cash flow stream. That would be the value of these dollars in today's money. So if I said, look, you can buy this investment for $50,000, would you pay $50,000 to get something that was worth $56,000? And of course you would. The other question we can ask is, what is the future value of these cash flows? If you were investing these, you're going to receive them and you're going to reinvest the money at this discount rate of 8%. What is that worth in value 5 years from now? And these cash flows would all be worth roughly $83,608 moving forward into the future. So again, this is just a more business-oriented kind of question, if you will. So what we want to do is we want to take a little break from this for a second, and let's think about asking some more applications questions. The first thing we might want to know is, what is the internal rate of return, or the return we actually receive on an invested dollar? Again, we use our time value of money spreadsheet. We bought an asset for $50 5 years ago, and today it's worth $75. What rate of return would you receive? Now you can solve for this interest factor, or you can use the spreadsheet. In this case, the beginning amount was the -50. We invested $50, cash outflow. It's now worth $75 over 5 years, and you leave the annual interest rate cell blank. That tells us that roughly 8.45% is the growth. It's the rate of return on this investment over the past 5 years. So again, let's think about this problem. Again, if you have your spreadsheet, you might want to put it on pause and work your way through the problem. You're going to buy 10,000 shares of stock at $2 in January of 2002. In January of 2006, you sell those shares for $3. What rate of return did you earn on your investment? And when you solve for this, you should ultimately find that the interest rate, or the rate of return, is 10.67%. Another very popular question is interest rate, or how long does it take for your money to gain value? There's really only one true application, I guess, that's kind of universally known, and that's something called the Rule of 72. And the Rule of 72 basically says if you take the number 72 and divide interest into that number, that will tell you approximately how long it takes for your money to double. And it's a very simple, easy, it's an approximation, it's not exact, but it does give you an idea of how money doubles and how things change based on interest. So what I would like you to do is watch this video. It's a little explanation of the importance and the application, if you will, of this type of a process, or this analysis of interest rates. Now, continuing on with our analysis, let's go back to some basic questions. Different type of cash flow in this case. Now we're talking about something called an annuity. An annuity is an equal periodic cash flow for a certain period of time. And these can be inflows or outflows one of the things we're going to assume for our analysis here is that all cash flows happen at the end of a period. This is what's referred to as an ordinary or a deferred annuity. Cash flows occur at the end of the period. And by the way, the spreadsheet, the Excel spreadsheet, and a financial calculator, all of these things assume cash flows at the end. So if you have anything that's different from that, you have to remember that you have to tell the spreadsheet or tell the calculator when the cash flows are occurring. Again, by default, they happen at the end of the period. So let's talk about a future value of annuity. Let's say you start when you're 20 years old and you invest $5,000 a year and you can earn average around 12%, and you want to retire when you're 60. How much money will you have in your retirement account when you get to 60? So we go to our spreadsheet again, the time value of money spreadsheet. We need to get rid of the future value and present value numbers that might be there. And then we enter 12%, 40 years. We're using annual cash flows because it's $5,000 per year. And down here where it says payment, we're investing $5,000 a year, so that's negative $5,000. So if you look for the value over here, the future value of an annuity, this is going to grow to $3.8 million. Now, will this make a difference if you did monthly payments rather than annual payments? If you take $5,000 and divide it by 12, that's $416.67. If you put that number in here as negative, change the compounding frequency to 12, the same $5,000 per year grows to $4.9 million. Again, another $1.1 million almost if you invest monthly instead of annually. So the compound frequency of money works very well for us. What's the future value of $5,000 invested at the end of each year for 10 years if the money earns 6% per year? Again, put the video on hold and plug these numbers into your worksheet, and let's find the answer. Your answer should roughly be $65,903. So again, make sure you can come up with the right answer. If you don't, work the problem a couple of times until you can figure out the proper way to enter the data. Let's say that you need $4.2 million when you get to retirement. You're going to retire in 45 years. You have 12% the interest rate. How are you going to acquire $4.25 million? What is that going to cost you? Well, the future value we need is $4.25 million. Present value is blank because we don't care about lump sums. Interest rates, 12% times 45 years. And again, I asked for monthly payments, so you change the compounding frequency to 12. And again, if you have this, any numbers down here, you got to delete these numbers down here. It turns out that to get the future value, to get $4.25 million, you need to invest roughly $198.09. Now, if this is a 401k and your company will match your investment dollar for dollar, how much money do you need to invest to get to $4.25 million? Well, if we average this up to $200 a month, if you invested $100 and your company matched that with $100, that would get you $4.25 million. But if you could invest $200 a month and your company would match $200 a month, this number would turn out to be $8.5 million. So again, we can utilize this process, this time value of money concept to ask and answer many, many questions about investing. We may also have some questions about loans. An amortization schedule basically breaks down the payments of a loan into its component parts. Every loan payment has part of it that is interest, and part of it that pays off the loan. So the day that you pay off one of these amortizable loans, the value that you own, the owe, is $0. On the day the last payment, the payment owed is $0. So here we have a $100,000 mortgage, interest rates 8.75%, it's the 30-year mortgage. What is the payment? Now I have a special worksheet for this. It's called the Loan Analysis Worksheet. Time value of money, loan analysis. Plugging in the numbers, 100,000, 30 for maturity, 12 for payments per year, and the annual interest rate 8.75%. Your payment would be $786.70 a month, If you made all 360 payments, you'd pay $283,000, which means $183,000, twice the amount of the loan, is what the interest would be. You might say that it would behoove us to pay off this loan sooner rather than later, certainly sooner than the 30 years that's owed. If on the worksheet, if you scroll to the right, you will find an amortization schedule. It lists the payments. Here's the beginning balance, $100,000. So when you make the first payment of $786, $729 of that is interest, $57 of that is principal. So then we end up with a balance of $99,942. Now next year's interest is based on the balance, right? This is compound interest, not simple interest. So the interest changes when the principal changes. In this case, since the principal is decreasing, the interest is decreasing. But we're making the same payment. So if interest portion is decreasing, that must mean that the principal payment is increasing. And you can see at 180 months, that 180th payment, halfway through, $575 is the interest, $211 now is the principal. And at the end of halfway, we owe $78,713 on this loan. How can we make extra payments maybe? If you look at the worksheet, there is a cell for you to put in a periodic payment. So let's say you wanted to add an extra month's payment per year. If you divide the monthly payment, $786, divide that by 12, that gives you $65.56. That will take a 30-year loan and turn it into a 22-year loan. So the amount of money you would save is $56,000, which might be something worth your while to save $56,000. So again, we can ask several questions with this, right? What is the loan payment? How much will it cost me to finance? Can I accelerate payments, right? All those things are questions that we can ask with respect to the time value of money and this loan question. So just briefly talk a little bit about loans, right? The types of loans that you have and you are qualify for frequently are based on FICO scores, right? So the FICO scores range from 500 to 850. 500 is very poor, 850 is outstanding. There are three basic types of loans. A prime loan, prime mortgage, is for those people who have outstanding credit scores. Maybe a 700 or a 750 plus would get you a prime loan. This basically means you have a sufficient capital to make down payments and you have good credit history. Prime mortgages that are referred to as Alt-A mortgages are really people who are working on improving their scores. Maybe they've had a credit problem in the past, but they do show some ability to make payments, and there are very low risk types of mortgage holders they'll probably pay off their mortgage. A subprime loan is for folks that have poor credit ratings or maybe just have high debt. These are considered to be high-risk types of mortgages. So the type of mortgage you get, the interest rate that you ultimately have to pay, primarily is based on your FICO score. So it's very important to keep track of your FICO score. That is the end of the time value questions. There are some problems in the homework, etc., that will ask you to solve some of these problems. So hopefully we'll get some practice in solving for time value of money.